Hey guys, welcome to eMath. Today we have another circle inscribed inside a parabola. And this time we need to find the coordinates of the center. So the first thing that came to your mind when you look at this question is again to find the intersection, right? But if you look at this graph, the curve, you'll notice that the circle and the parabola will have two intersection points, right? Which means when you solve for the system of equation, when you put the equation of circle and equation of parabola together, you are going to get two solutions. This is what we know. And another thing that I want you to take note is, let's say this is a point P. Let's say we call it X, Y. It doesn't matter which alphabet we give to the point. If you draw a tangent line to the parabola at that point, it is also the equation of tangent to the circle at that point, right? A simple geometric proof is like this. You simply draw a radius connected to the center of the circle. You'll notice that it is always perpendicular. Okay, which means if we are able to find the equation of tangent to the parabola and the equation of tangent to the circle, we can equate them together to form another equation to get rid of some unknowns, right? So here's the thing. We have two things that we need to do. Number one is to find the intersection and express something in terms of some things, and we'll know what to find later, right? And number two, we want to find the equation of tangent for both of them and equate them together. But before we begin, let's give coordinates to the C here, okay? This point C, because we can see it already, it lies on the y-axis, which means the x coordinates is equals to 0. Okay, so C is 0. And what about the y coordinates? That's what we need to find, right? Let's call it maybe B, okay? So that it is easier for us to form the equation of the circle later. And I think I will form it now. Okay, so the parabola is y equals to x squared, very simple. And the circle is, the center is 0 and b, x squared plus y minus b squared equals to, the radius is given 1 squared, okay? So the first thing that we want to do is to find the intersection, which means we let this be equation 1, let this be equation 2, substitute equation 1 into equation 2, we get, okay. Who should we eliminate? Should we substitute y with x squared, or should we substitute x squared with y? Here's the thing. See, we are looking for the y coordinates of the center, which means because we already know the x coordinate, right? Which means at the final few steps we are looking at y equals to something, b equals to something. So I think we should eliminate our x squared here, okay? Which is y plus y minus b squared equals to 1. Is that right? Yep. And I think I will leave it like this. First, see what we can get from the tangent line. Maybe we can simplify this one. I don't know. Maybe we get the square root there, directly cancel out with the square here, so that we don't have to do double work, so that we don't have to expand the bracket here. Okay. Anyway, I will leave it like this here as equation 3. Okay, and I will continue this later. Okay, then what about the equation of tangent? Very simple, differentiate. Okay, so for the parabola, You differentiate this, you get dy dx equals to bring down the power minus 1. For the circle, okay, for the circle, because as you can see, it is like you can't express y explicitly in terms of x. So you just do what we call implicit differentiation. 2x plus bring down the power, okay, not sure if you can see this, power minus 1, differentiate inside because of chain rule, differentiate a constant, you get a 0. Okay, then you just try to rearrange it. Dy dx equals to, okay, before that I think we can cancel out this 2 and 2. Negative x over y minus b. And you know what? I think I will multiply both top and bottom by negative 1. And you'll see why later. Okay? X over b minus y now. Okay? So let's call this as y prime 1, and this is like y prime 2. Since y prime 1 is equals to y prime 2 as established above, we said that they have the same equation of tangent at those intersection point, right? So we can say that 2x is equals to x over b minus y. And I think you know why I want to have a positive x. Because I want to directly cancel out my x here. So 2b minus 2y is equals to 1. And what do we want? We want b, right? So b equals to, okay, 2b equals to 2y plus 1, b equals to y plus half. Is that right? Yes, huh? So let this be equation 4, and we'll continue here. Okay, so we substitute equation 4 into equation 3. Not sure if this works. Y plus y minus y plus half square equals to 1. See, I told you, that's why I said don't expand the bracket, the square first, because y and negative y can cancel, and technically this is negative half, but doesn't matter because you are squaring it. So y equals to, okay, almost set for you, plus 1 over 4 is equals to this 1, sorry, 1. So y equals to 3 over 4. And you know what? Just now I should have expressed y in terms of b to solve for my b. But it doesn't matter, because if we do that, maybe we can do the shortcut like this, right? Anyway, you just substitute this back here. You get your b equals to 3 over 4 plus 1 half, which you will get 5 over 4. Okay? Hence, the coordinates of the center is 0 and 5 over 4. And that's it.